Hello, good afternoon, or good morning, depending on where you are. Welcome to this this webinar on the 2022 hurricane season. I am Keith Porter, your host, Chief Engineer for the Institute for Catastrophic Loss Reduction, Canada's leading source for disaster resilience knowledge. ICLR offers an annual forecast of the year's wildfire and hurricane seasons. Today's talk on hurricane season seems timely, since Hurricane Agatha in southern Mexico set a record today as the strongest May hurricane in the Eastern Pacific. Today's speaker is Bob Robichaud. Bob serves as Warning Preparedness Meteorologist at the Canadian Hurricane Centre, a division of the Meteorological Service Canada. Bob has been a meteorologist since 1995, most of that time with Environment Canada. He's based in Halifax, where he works with emergency managers in weather preparedness and response. Bob will speak for about half an hour, give or take, and then I'll moderate Q&A. Please feel free to enter questions in the Q&A box at any time, and I'll relay them at the end of Bob's talk. So take it away, Bob.
All right, thank you, and thanks everyone. Welcome to the 2022 hurricane briefing, kind of an annual event now. Some of the topics are pretty much the same from year to year, but it's certainly the content changes based on the hurricane season. So we'll do a quick refresher of tropical cyclones. We'll do a review of last year before moving on to look at what some of the indicators are for this upcoming hurricane season. So tropical cyclones are kind of unique, or at least a little different than the typical fall and winter and spring storms that we get for a number of reasons. One is that the way it actually forms. So these storms are large-scale storms with uniform characteristics with respect to temperature and humidity. So they form over the tropical Atlantic due to the warm water there. And one of the criteria that we have to call a storm a tropical cyclone is that it has a very well-defined center of circulation. So what we do is we monitor the tropics over the course of hurricane season for these things to develop, and then once they develop, the maintenance of this storm depends totally on things like wind shear and water temperature. So as long as it has warm water and the wind shear is fairly low, this thing will maintain itself until that source of fuel, which is the warm water, is cut off. So you see where these things develop over the tropics. Some develop over the subtropics, so just outside the tropics. Those tend to be sometimes early in the season or later in the season. Now, there is kind of some complicating factors when we look at these types of storms. There's the case where we have a purely tropical cyclone, in that it forms as a cluster of thunderstorms that gradually become better organized, and then it develops that center of circulation, and then ultimately the winds reach 63 kilometers per hour, and then the storm gets a name. But there's actually another way that these things can form, and that is with an existing area of low pressure, one that derives its energy not from the warm water, but rather the temperature difference between southern and northern latitudes. So when we have one of those storms that actually starts to acquire tropical characteristics and then becomes a tropical cyclone, we call that a subtropical cyclone. So this process can actually go in reverse as well. So we can have a storm that is either a subtropical cyclone or pure tropical cyclone. But what happens over time is that this will, especially when it reaches some of the northern latitudes, what will happen is that it will start to transform itself into a storm, not that derives its energy from the warm water, but rather that north-south temperature gradient. And we call those storms post-tropical once they reach a point where the majority of its energy is from that north-south temperature gradient. Those are the storms that we tend to get a bit more here in Canada than the pure tropical variety. There are things that we know can happen with these post-tropical storms. They speed up. Usually what happens on the right-hand side of the track is it dries out as most of the moisture switches over to the left-hand side of the track. However, on that right-hand side, that's where we have the strongest winds. The storm actually gets bigger as well. So a lot of these post-tropical storms tend to be bigger than the original tropical storm or hurricane that actually caused it in the first place. So we categorize these things once they develop and they reach a certain threshold. I mentioned 63 kilometers per hour. That's when the storm gets a name, once it has that well-defined center of circulation. And then when the winds reach 118 kilometers per hour or above 118, that's when it gets classified as a hurricane. And then above 178, that's when it gets classified as a major hurricane. And all the way up to category 5, which was kind of an open-ended category. So anything above maximum sustained winds of 151 kilometers per hour. So if we look at the climatology, I've showed this before as well. We can see that early in the season, some of the early storms tend to develop in the Gulf of Mexico or off the east coast of the US. As we head into July and August, the area where they tend to form the most tends to migrate a little bit towards the east, September being the peak month of hurricane season. And then things start to wind down again in October and then November. So that covers all of hurricane season. Looking at this a slightly different way. So I mentioned that hurricanes like environments that don't have a lot of wind shear. So wind shear is a big component as to if we're going to get a lot of storms or how intense they're going to be. So over the winter months, where the extratropical storm tracks are further to the south, there tends to be a lot more wind shear in the tropical Atlantic than in the summertime. At the same time, the water temperatures kind of reach a minimum once we're in the winter months. However, once we get past the equinox in the spring, that water temperature starts to go up. So the water starts to warm up as we head further into the spring and early summer. And the peak water temperatures actually occur in late September to early October before they start to dip down again. So there's a lag there. With respect to wind shear, the wind shear starts to decrease as that storm track for the spring and winter type storms starts to migrate further north. That wind shear in the tropical Atlantic decreases and actually reaches a minimum in August to early September. But then in September it starts to creep up a little bit. So the peak of hurricane season falls right in the middle of these two the minimum for wind shear and the maximum for water temperature. Luckily, these things don't perfectly line up. Otherwise, we would have much more catastrophic hurricane seasons than we do now, as bad as they can be right now. So that peak for hurricane season lies right between those two maximum, minimum, and statistically is around September 10th as the peak of hurricane season. So in terms of forecast responsibilities, the National Hurricane Center in Miami, they're part of NOAA. They're what we call the Regional Specialized Meteorological Center for the World Meteorological Organization. Regional Association 4. So basically what that means is they are responsible for issuing track and intensity forecasts for the Atlantic and for the Eastern Pacific. So in contrast to us at the Canadian Hurricane Center, we're not in competition with them, where we actually work quite closely together. We send a couple of people down there every year for some training, notwithstanding the last couple of years due to the pandemic. But what we take is some of that information. We take we produce our own forecasts on storms that are expected to cross into our response zone, which is indicated there on the graphic to the right, within a 72-hour period. So 72 hours before the storm enters that response zone, we will begin issuing information statements and track information, intensity forecasts, and all that as well for these storms. So there's two sources of information. It's at everybody's advantage that we coordinate very closely to make sure we don't have two different forecasts out there. So we do coordinate quite a bit, especially with some of the tools like MS Teams and those types of things over the last few years have really facilitated that coordination. So we're into this is our 35th year of operation at the Canadian Hurricane Center. And we'll see at the end here how you can get some of the information that we have when a storm is approaching Canadian territory. So moving on to taking a look at what we had last season, 2021. These are all the storms that we had over the course of the season. And we exhausted once, excuse me, we exhausted once again the list of hurricane names that we had at our disposal with 21 named storms. The storm ended with Wanda, so we didn't have to actually resort to using our supplementary list that we have at our disposal. But this was only the third time that we used all the letters in the storm names that we have. Not all names, not all letters of the alphabet have a name attached to it. So we have 21 and we used all of those. It was only the first time ever that we had exhausted our list 2 years in a row. So looking at what actually happened, as I mentioned, we had 21 named storms. 7 of those became hurricanes and 4 reached major hurricane status. And you can see how that fits into the predicted numbers there from last year from NOAA. So you can see the distribution of hurricanes and tropical storms at the bottom there. Ida was the storm really in terms of impacts in 2021. So that storm was pulled from the list of names. Those list of names, by the way, is a recurring list. So it comes back every 6 years minus whatever storms that are retired. So Ida will be pulled from that list and never to be seen again as a named tropical cyclone in the Atlantic. So these are all the tracks of the different storms from last year. You can see pretty much well distributed over the entire Atlantic. There's a bit of a black hole north of the Caribbean and east of the Bahamas there, where there weren't too many storms that actually entered that area, but everywhere else there was a good sprinkling of storms in there. We had 8. I mentioned our response zone, our CHC response zone. We had 8 that actually entered our CHC response zone. So we'll take a quick walk through the season. Last year was the first time, well, it was the record 7th consecutive year that we had a storm develop prior to the official start of the season, which is June 1st. So we had Anna last year. Then Bill was another one of these short-lived storms, kind of a subtropical storm or storm of non-tropical origins that developed early in the season as well in June. Then Tropical Storm Claudette became the first pure tropical storm of 2021. So there's no no subtropical characteristics to Claudette when it when it actually formed, and it made landfall in Louisiana. It was an interesting case as it got close to being declared a tropical cyclone, but was only declared a tropical cyclone after the center had made landfall. So it did acquire some extra energy as it moved in over some warmer kind of swamp areas, but it was officially a storm that actually formed over land that you don't see too often. Now, it did result in some impacts. There was some flooding and some fatalities reported with Claudette. And then we had Tropical Storm Danny that formed late in June, but didn't result in much in the way of impacts there. Then Elsa formed at the end of June and ultimately became the first hurricane of 2021. It made landfall in several locations as a tropical storm, but even as kind of a weaker storm in terms of wind intensity and all that, it still resulted in over $1 billion in damage and 13 fatalities. So after about a month of relatively quiet activity in the Atlantic, once again in early August, we had our next storm, which was Fred. Fred produced over 250 millimeters of rain in a short period of time as a tropical depression. So again, when we see some of these characterizations of storms in the media, people tend to kind of brush it off, but this storm actually had quite a bit of impacts as a tropical depression. There were actually 6 fatalities over again over $1 billion in damage from that particular storm. So then later in the season, a tropical wave formed off the coast of Africa, became Hurricane Grace. And that ultimately became the first major hurricane of 2022, of 2021, sorry. And unfortunately, it did have some impacts over Haiti, which was recovering from an earthquake, 7.2 magnitude earthquake just a few days prior to that. There were 16 fatalities and over $500 million in damage. Then we had Henri, that was the 3rd hurricane of the season and caused all kinds of problems to folks in New England. It became a hurricane and it looked like it was going to continue to intensify, but it actually weakened, made landfall, stayed in place for a little while before moving back over the water. It did result in some flooding and a couple of fatalities, but what it really did, it kind of set the stage for the next storm and created those antecedent conditions for when the next storm came, and that was Ida. And Ida ended up being the most powerful or impactful storm of the 2021 season. It originated as a tropical wave off the coast of Africa, but didn't really get going for a while. We were tracking this all the way across the Atlantic, and it was only after it crossed Jamaica that it was actually given the name Ida. So it took a while to really get going, but once it did, it really got going because it went through rapid intensification, ended up making a landfall as a Category 4 in Louisiana, which happened to be 16 years to the day after Katrina made landfall back in 2005. So Ida produced catastrophic damage in Louisiana, also some deadly flooding in the northeast US as a post-tropical storm. The damage estimates, clearly Ida was the most destructive storm of 2021 with $75 billion in damage, and 55 fatalities occurred as a result of Ida. And it's interesting to look at some of the impacts here from not necessarily just the Louisiana kind of region, but also in some of the northern latitudes. These are all pictures from Pennsylvania, New Jersey, and New York. If we look at the distribution of the fatalities with Ida, we tend to categorize them as indirect or direct. So direct would be something that is directly caused by the storm, like a tree falling or that sort of thing. Indirect would be fatalities that occur like a weather caused or related car accident or any kind of fatality after the storm is over, as people go out and kind of look at the damage and all that stuff. So if we look at the indirect fatalities, most of the indirect ones were in Louisiana, where the storm actually made landfall as a major hurricane. And most of these, some are a result of damage after people checking out damage after the storm, but most of these are a result of heat exhaustion as a result of not having any power. So the whole area was out of power, and it was very hot and humid in the days following the storm, and that's what contributed to the fatalities there, as opposed to the actual storm itself. However, if we look at the direct fatalities, there were fewer of them along the Gulf Coast, but most of them occurred in the New York, New Jersey, Pennsylvania area. Those were as a result of the flash flooding that occurred in some of those heavier rain bands associated with the storm as it was tracking through that area. Some areas got close to 100 millimeters of rain in an hour. So that's interesting to see how that actually developed. And if we go back and look at the track here and see what's plotted on here is actual rainfall. Obviously, the waters off Canadian coasts are not warm enough to sustain a major hurricane. But what transpired in that Pennsylvania, basically the mid-Atlantic states, including New York City, is definitely something that could happen here in Canada very easily, and has actually happened before. So, you know, the fact that it happened there could have just as easily happened in Southern Ontario, Southern Quebec, or somewhere in Atlantic Canada. So we actually did get some significant rainfall from Ida. A lot of areas got in excess of 50 millimeters in a short period of time. Some actually exceeded 100 millimeters. That resulted in a shutdown of some of the commercial shellfish harvest along coastal areas of the Gulf of St. Lawrence for an extended period of time. Then as we continue into walking through the season, we had Kate, Julian, and Mindy. Those were all late October and early September storms with little to no impact. Then we had Hurricane Larry. Larry was one of those classic long-lived storms that developed off the coast of Africa, and eventually became a major hurricane before making landfall in Canada after weakening a little bit, and made landfall as a Category 1 hurricane in the early morning hours of September 11th. So that was the first hurricane to make landfall in Canada, pure hurricane, because it had not transitioned to post-tropical at that point just yet. So it was the first hurricane to make landfall since Igor back in 2010. So significant amounts of damage in Newfoundland. There were 6 fatalities, none in Newfoundland, but most of those were as a result of rip currents along the east coast of the US. The pictures I have up there now were of a tent that collapsed, that was destroyed by the storm. There was supposed to be a concert there that night. That was ultimately canceled, thank goodness, and ultimately that destroyed that particular venue. So there was over 60,000 customers had lost power. Roof blew off a school. There was some storm surge damage as well. Not much in the way of rainfall, just because the storm was moving fairly fast when it went through there. But the rain that they did get fell in a very short period of time, but there wasn't a whole lot of flooding. It was mostly wind damage and storm surge damage with Larry in Newfoundland. So then later in the season, we had Category 1 Hurricane Nicholas make landfall in Texas. There's some road washouts there. Again, easily getting up to $1 billion in damage. And then we had a few weaker storms towards the end of the season. And then came the strongest storm, which was Sam, with peak winds of 250 kilometers per hour. That was the last major hurricane of the season. That one actually did also enter our response zone, but far enough away from land that it didn't cause any issues there. So to end the season, there were 3 tropical storm intensity storms with Teresa, Victor, and Wanda. So this is just a quick distribution of the storms by month. Obviously, you can see that the August, September were the really busy months. In the last few years, we've seen it spill over into October and a little bit into the early part of November, but that wasn't the case last year. Most of our really busy time was August and September. Just looking at some numbers here. There were 58 eyewall penetrations from the Hurricane Hunter aircraft, over 450 hours flown, 1,300 drop-sons deployed. Looking at some of the other numbers here, 21 named storms, the 7th straight year that we had at least one storm prior to the start of the season. It was a 6th straight above normal year. 8 storms made landfall in the US. 8 storms also entered our Canadian Hurricane Center response zone. Obviously not the same storms, but again, we had 8 that entered our response zone. So over $80 billion in damage, which is actually more than the damage reported during the record season of 2020. And obviously most of that is with one storm, and that is Ida, and close to 200 known fatalities from last season. So with that, what might be in store for this hurricane season? Again, this doesn't change from year to year. It's simply the factors that influence hurricane season. As I mentioned earlier in the presentation, water temperature and wind shear are probably the biggest 2. And we also have something called the Atlantic Multi-Decadal Oscillation, which is kind of a cycle that occurs over the course of about 20 to 40 years, where we see periods of active hurricanes and periods of relatively less active hurricane seasons. So if we look at water temperature, we'll start with that. In the Atlantic right now, water temperatures are pretty much above normal in the area of concern for tropical cyclone development. So more so off the east coast of the US, just a little bit off the coast of Africa and in the Gulf of Mexico. Another thing that we look at is whether the water temperatures are colder than normal in the Pacific, just off the coast of South America, so the equatorial Pacific. When the water temperatures there are colder than the long-term average, we call that a La Nina. And when we have a La Nina, we tend to get lower wind shear in the Atlantic over the course of hurricane season. So both of these things here are pointing towards low wind shear and warmer water in the Atlantic. So if we look at the water temperature in the Atlantic, just a closer look here. Again, there's a slight area of below normal water temperature. It's actually, it's showing up as blue, but it's just barely below average. Everywhere else of concern where these things develop, the water is already at this point warmer than the long-term average. But what's important is, how's it going to look once we hit the peak of hurricane season, which is August, September, and October? Well, some of the long-term projections for water temperature is, again, that band of warm water into the Gulf of Mexico and all along the east coast of the US, including off the coast of Canada as well. And there's a little patch of warmer water off the coast of Africa. So that'll help get those classic type Cape Verde storms going as well. And this is actually a month old, and it gets updated tomorrow. So we'll see what that has in store for us. Looking at whether we are going to be in a La Nina or El Nino situation, looking at the peak of hurricane season, the ASO, which is August, September, and October, the latest predictions are that there's a 57% chance that we're going to remain in a La Nina situation, 39% chance that it might dip to neutral, but only a very, very small probability that we're going to be in an El Nino situation, which could keep the numbers of hurricanes down. So everything there is pointing towards an active season, as does the water temperatures. And finally, the multi-decadal oscillation that I mentioned earlier is just an alternating active, inactive phase. We've been in an active phase now since 95, and we continue to be in one. So all these factors working together, again, point to another active season, which would be the 7th in a row. Looking at some of the predictions, Colorado State, really the grandfathers in issuing seasonal outlooks, are calling for 19 named storms. Tropical Risk, which is a consortium from Europe, they look at this stuff as well. There's about 22 agencies that try to issue predictions for the hurricane season. These are the main ones here. UK Met, they came up with theirs. It was Monday of last week. They're calling for 13 to 23 named storms. NOAA came up with theirs on Tuesday of last week, and they're calling for something very similar. And you can see how those numbers stack up to the average of 14.2, 7.2 hurricanes, and 3.2 major hurricanes. So everything's pointing towards an active season once again this year. These are the names we're going to be using for 2022. So we're actually monitoring what's happening in the Pacific, and there's a possibility that the remnants of Agatha could generate some activity later this week in the Gulf of Mexico. If that does become a tropical cyclone, it would be named Alex, and then followed by Bonnie, Colin, and so on. Now, if we do get through this list, then we have to go to our supplemental list. This is, again, the list that has replaced the convention of using the Greek alphabet. So we've moved away from that, and we have the supplemental list that we can use every year, while this list rotates every 6 years. This is the list, the supplemental list that we have every year in the event that we run out of names. So finally, just the best place to get information on these things when they develop, especially when they don't necessarily have an imminent impact expected in Canada, that would be at the National Hurricane Center website. As a variety of different information sources on there. And then once a storm actually approaches Canada, our hurricanes.ca website is where you'll find our track maps, our intensity forecasts, and our information statements. We also have all this information on our app, the new WeatherCan app, and over the years, our Twitter followers have been steadily growing. So we try and, as that list of followers grow, we try and keep that as current and focus on getting information out via Twitter as much as we can. So with that, I'll wrap it up, pass it back to you, and open to take any questions.
Awesome. Thanks, Bob. We have no questions from attendees. Please feel free to use the Q&A box to ask your questions. So I got one, Bob. You gave us a bunch of numerical indicators for the coming season, And for the last, you gave us some for recent history. The seventh severe season in a row. Which of these, or do all of them, are all of them in signals of climate change? And at what point do we, sort of define a new normal?
Yeah, what we do is in terms of the normals that I talked about, we treat the number of storms very similar as to what we treat the regular kind of weather parameter normals, like temperature, precipitation, that sort of thing, wind, all that stuff. So we tend to go with a 30-year average. So right now, the averages that we're talking about, like the 14 named storms over the course of a season, that is essentially the averages from 91 to 2020. They were actually adjusted last year, and it went up from 12 to 14. So the average number of storms has actually gone up just in the last year. So we used those normals for last year. One of the things that we have to be careful about in drawing conclusions from that is the tools that we have at our disposal to actually detect these storms. The satellite imagery that we have now is hard to compare to what we had just 10 years ago. It's amazing the stuff that we can see now with those higher resolution satellite images. We have other devices that will actually measure the ripples on the water and correlate that to a wind speed, so we can detect some of these stronger winds better than we ever were able to in the past. So if we compare some of the storms that we're seeing now compared to just 10 years ago, we're definitely seeing more of them. And if you break it down to the number of storms, like when I walk through the season, there's a number of them that were weak storms. They formed over a period of time, and then they weakened without lasting an extended period of time. Those are storms that probably even 10 years ago wouldn't even have been detected, or would not have been a named storm, but they are now, just because of the tools that we have. So we got to be careful when we analyze some of these numbers as to what it actually means.
Gotcha. Stacey O'Brien asks, you said 57% chance to remain in La Nina and very unlikely to go to La Nina. El Nino. Is being in El Nino worse than being in La Nina, or is either one just as dangerous as the other?
No, in terms of hurricanes, at least, when we have an El Nino, that creates more wind shear in the tropical Atlantic. So when we have more wind shear, we tend to have fewer storms. So an El Nino, in terms of hurricane formation, would be a good thing because it would keep the numbers down. But again, looking at the wind shear over the entire tropical Atlantic, even in a year where we do have an El Nino, you could get these periods of a week or two where you have certain areas in the Atlantic where the wind shear drops off dramatically, and that opens up a window for a very, very strong storm, even in the year where there might be a lower number of total storms. So that's why we kind of put that out there, because obviously if we have a La Nina, there tends to be more storms. When we have an El Nino, there tends to be fewer storms, but there's still that window of opportunity for that one storm to develop and wreak havoc, like we saw last year with Ida, for example.
Cool. Still no new questions from our attendees. So I got one more. I've been involved lately, or sort of been watching the evolution lately of the National Adaptation Strategy. Has the Canadian Hurricane Center been involved, or have you been involved at all in the development of the National Adaptation Strategy in light of your hurricane expertise?
Yeah, we're the Public Safety Canada, for example, has a national risk profile that they're in the process of building. And we've been heavily involved with that over just the last 6 months, really, in developing different hurricane scenarios. So we've developed one, basically hurricanes of different scales that would affect areas in Canada. So we've developed the one that would be kind of a hurricane, but not necessarily generating a whole lot of impacts, all the way to another storm that would be kind of a Sandy-like scenario, but instead of making landfall somewhere in New Jersey, it might make landfall somewhere further up the coast into Maine, closer to the Canadian border, which would have a whole load of other impacts in Atlantic Canada, in southern Quebec, and in southern Ontario as well. So we've been working with Public Safety Canada on that over the last few months, actually.
Interesting. Let me follow up. So that's for a disaster planning scenario? Is that what you meant by a scenario?
Yeah, it's the national risk profile. So it's just analyzing risk of various things. Like in our involvement, it's been tropical cyclones, but there's other things like just weather related, like the heat dome situation that they had in BC, and atmospheric rivers, that sort of thing.
Cool. Barbara Bethune, sorry if I've mangled your name, Barbara, asks, how did the derecho develop last week?
Yeah, I've been 100% immersed in hurricane stuff, so I haven't been able to really follow in detail how that occurred, but it was certainly an amazing event and a widespread event, looking at all the damage in Ontario and southern Quebec. It was amazing to see the level of damage and all those massive trees that were basically blown over or snapped. It was quite an impressive event from a weather perspective.
Yeah, it was impressive.
It was certainly not tropical related. That's I can tell you that for sure.
It was impressive to sit and watch it from my porch. Well, Bob, that we don't have any additional questions either in the chat box or the Q&A. Is there any final thought you'd like to leave us with?
No, I guess the last slide that I have up here, and that's always the thing, is that it's people like to know how busy the hurricane season is going to be, as in how many storms we're going to get. And although it's an interesting little tidbit of information to have going into the season, but this year, 2022 marks the anniversary of Hurricane Andrew in 1992, and that particular year there were only 6 named storms. I mean, we hit 30 2 years ago, 21 last year. That year there was only 6, but one of them was Hurricane Andrew that basically devastated South Florida. So it goes to show that it doesn't matter so much how many storms there are over the course of the season. It's that one storm that could impact you that makes all the difference.
Yeah, absolutely. Okay, so thank you so much. Hope Parnham asks if Bob's going to be sharing his slides. We are recording this presentation, so look for the recording of this presentation on ICLR's webpage within a couple of days. Bob, thank you so much for another great forecast for the coming hurricane season, and Really enjoyed the look back at last year's. That was very informative. Everyone else, thank you so much for attending, and we'll see you next time. Bye-bye, everybody.
All right, thank you.